very recently, we have started working with water quality monitoring. Now, some people from UAE came up to us and said they have a lot of desalination plants that the entire coast. What happens though is that the intake of water at these places is sometimes clogged up with what is called an algal bloom. Algae are present in most open water bodies and they're not a problem. However, when they multiply and there's a huge ton of them, they start to clog up waterways. And they also cover the surface of the open water such that what's underneath doesn't get enough light, and fish tend to die. This poisons the water. So fish die, that's not good for fishermen. People who drink the water are sick, that's not good for people either. And the industrial water treatment plants are affected. So in general, there is a need for algal bloom prediction. And that's where we decided to head. We decided to make a sensor that can not only sense when huge amounts of algae are present in the water, but also what kind of nutrients are required by these algae to grow. So if we can sense both the algae and the chemical nutrients simultaneously on the same platform, bingo. We can then predict an algal bloom event and help prevent all the losses. The Defense Threat Reduction Agency is interested in sensing air quality and also wanted to monitor areas where there may be some illegal activities going on. For example, nuclear weapons and so on. So they were interested in our sensors, our chemical sensors. Can we detect chemicals, small quantities of them, that are used in contraband activities? That will give them an idea or a clue into what parts of the world are doing things that they're not supposed to be doing. So we moved into chemical sensing for defense applications as well. So defense threat reduction is what we're also working on. Now, in these sensors, the agency envisions them to be hockey puck sized, and they can be disposable because they're low cost. They can be scattered around in battlefield areas, and those can be remotely monitored by us to say whether or not there's certain activities going on in the vicinity. So that's the idea. Our sensors can be their own unit, battery-operated units that are scattered around in areas of suspicion. And then we can monitor remotely where these chemicals are prevalent. There's a large application space in the oil industry as well. For example, oil pipelines today have flaring as a common method for getting rid of high pressure areas. It's a waste of the gas. However, what oil industries need is a way to sense remotely where there's an excess buildup of a certain gas and where the next flare should be started. And in general, the entire pipeline needs to be monitored. If it can be done remotely, that would be a very, very good thing for the oil industry.